Part B, explain why there must be a value of C. Sounds like intermediate value theorem or mean value theorem between -1 and 1 such that f double prime of C equals 0. So I'm thinking, since I see a derivative, this is a mean value theorem. But usually mean value theorems, we're talking about the first derivative. So if we're talking about the second derivative, we're kind of a step down. So if we're talking about the second derivative, we have to go to the original function, well, the step above. Like usually we're talking about f prime of C equals 0, which we talk about f. But if we're talking about f double prime equals 0, we're talking about f prime. So we're going to apply the mean value theorem, and usually it's this: f of 1 minus f of -1, that's from A to B, over B minus A. Again, that's if this were f prime, but it's not, it's f double prime, so, let me do that. So, we'll just go f prime of 1 minus f prime of -1. Now, we're going to figure out what that is, but the mean value theorem applies if your function is continuous and differentiable. So I would state, since f prime is differentiable, and here's the mean value theorem, we're assuming this is going to equal 0. If it doesn't, then we have problems. So let me move this over. We'll calculate this. F prime of 1 according to the chart is 0. F prime of -1 according to the chart is 0 over 2, which equals 0. So it's exactly what we wanted to happen. Since f prime is differentiable and this is true, that means by the mean value theorem, there must be some value of C that f double prime equals 0. So that works out nicely. Part C is nice.